Hey, what's going on, guys? 30 here.
And welcome back to another Minecraft modding tutorial for version 1.18. In this tutorial we're going to be covering item capabilities. So this is a way of saving items inside of our block entity. This is actually fairly simple to do, so let's just go ahead and let's get started with it. So for this tutorial I'm going to be creating a new class which will be sort of an abstract layer between your block entity and the actual block entity class. So it's essentially a utility class, if you think of it like that. So what I'm going to be creating in this tutorial is I'm going to be creating a drawer, and it will simply hold one type of item, and it will hold up to a large number. I forgot what number specifically, 32,700 and something. And it will hold that number of that singular stack of items. And it's actually very simple to do this way. In the next tutorial I will be covering containers, and then I'll be covering screens, or I might do those both in the same tutorial actually, because they're kind of attached to each other. So let's get started. Let's come into our block entity package and let's create a new class. Now I'm going to call this class inventory block entity, and you're going to want to make sure this extends block entity. Okay, and let's finish. Now we're obviously going to want to change these to be what they actually are, so type, pause, and state. If you're wondering what key I did in order to change both of these at once, in Eclipse that is Alt-Shift-R, and then you just start typing and it will change all of them, and Enter will actually refactor it. Let's get rid of this white space up there. Now actually let's add that white space back, because we're going to need some fields. So first we're going to need a integer, which is the size of our inventory, so how many slots it can hold. So we'll have a protected final int size. It's final because we only want it to be able to be set once, and we're going to now want to take that size in our constructor and do this dot size is equals size. Now we could even add some validation here, so we could say if size is less than or equal to 0, then size is equal 1. Okay, you could do something like that and then say this dot size is equal size. In fact, I'm going to do that because just to make sure you actually put in a correct value. We don't want to accidentally create something with an undefined size. That wouldn't be very good. Then we're going to want an integer which is for a timer. Now we'll just use this for ticking stuff. So protected int timer, and then we'll have another field which is a protected boolean, and we will use this for determining whether our block entity needs updating, since basically we're going to be messing around with capabilities and we need to make sure it's updated when things are changed. So I'm going to have a boolean here called requires update, and when this is ever true we're just going to update the tile entity, or block entity I mean. And there are two more fields that we're going to want. So let's actually create the inventory itself. So to do that, we're first going to want a protected final item stack handler, and we'll call this the inventory. Then we're going to want a protected lazy optional of item stack handler, and we'll just call this the handler. Just import lazy optional. And I'll explain what these are in a second. Right now that will probably be a bit confusing to explain. However, we do need to go ahead and set these in the constructor. So this dot inventory is equal to, and this is going to be a method which we'll create in a second called create inventory. That'll just create it for us. And then we'll do the same with the handler. So this dot handler, but this time it's going to be equal to lazy optional dot of, and then we just want a simple supplier of this dot inventory, like that. Okay. Now let's create this create inventory method. So we can make this private, and it will be an item stack handler. Create inventory. Now in here we're just going to want to return a new item stack handler, and that's going to be the one that takes in an integer, which will be this dot size. Now we're going to want to make this an inner class, just like that, and we're going to want to override two methods. So we're going to want to override extract item and also insert item. Okay, and just before, actually we'll leave that for a second. Yeah, we'll leave that. So let's now create our capability stuff. So we're going to want to override get capability. The one that takes in the side is preferable. And in here we're just going to return cap, which is the capability that's being passed in, is equal to, and since our capability is an item, we need to use capability item handler dot item handler capability. If it is, then we'll use this dot handler, and we need to cast that. So that gives us the lazy optional that it wants. It's simply just casting this item stack handler to whatever this is looking for. As you can see here, it just returns it like that. And if not, we'll just say super.getCapability. Now, if you have multiple capabilities, you're probably just going to want to change this to a if statement instead of inline if statement. After we've done that, let's create two getters in this class. Let's create a get handler, and let's create a get inventory. There we go. Let's also create a getter for the size. Get size. In fact, it's final, isn't it? So we can just make this public. And in fact, we can also make this public because that's also final. So we don't need that. There we go. Cleaning it up a little bit as we go. Now we're going to want these same methods that we used in the last block entity tutorial. So if we come into here, you can see we made our handle update tag, get update packet, etc, etc. So we're going to want those. First, let's do get update packet. And as in the last tutorial, we just return client bound update. No, client bound block entity data packet dot create this. Then we're going to want get update tag. Now here's where I want to mention something I did differently in the last tutorial. So in the last tutorial, when we come down to somewhere, here we go, get update tag. Now I previously had something along the lines of save a new compound tag, right? So if you check the last tutorial, you'll see that I had it like this. However, as of recent Forge versions and as of my recently gained knowledge, this save method is basically broken at the moment. So we need to actually use save additional. Now you'll see I've already changed it in here because it was causing some issues. So all you need to do is change every save method to save additional, and inside of get update tag we need to change save to serialize NBT. So that is just one difference from the last tutorial. Let's just plonk that in here as well, serialize NBT. Then let's do handle update tag. So we'll call the super and then we'll just load tag, simple. And what's the other one? The other one is on data packet. Okay, we will call the super and then we'll just handle update tag. And that is packet.getTag. There we go. Now we're going to want to override the two saving, so the saving and the loading. So we'll override save additional. And this is the tag. Oh, what the hell? Okay, Eclipse. Sure. So we'll just call the super in there as we always do. And simply to save our capability, we can do compound dot put. Oh, it's tag. Okay. I always name it different things. I don't know why. So I want to put tag dot put, and then let's go inventory, and for the actual inventory, we're going to want this dot inventory dot serialize NBT. Fantastic. So that's our save method. And then we're going to want load as well. So we'll call the super.load once again. And this time we'll just use this.inventory dot deserialize NBT tag.get compound inventory. This way it's basically all being done for us. Now we need to go back to our capability stuff, and we need to make sure our capabilities are invalidated. So you can override the invalidate caps method. Now essentially what this method does is it is just called when the block entity is removed. It makes sure the caps are invalidated so they don't sort of persist when they shouldn't be. So we just need to make sure every capability we have gets invalidated. So our only capability is this.inventory. So you may think we would just do invalidate, but that's not correct because we actually need to invalidate the lazy optional. So it's this.handler.invalidate. There we go. Make sure you keep the super here as well. In fact, some of this might be done in the super anyways, but just in case it's not. And is there anything else? Yes, there is. There's a few things else that we're going to need. So the first thing that we're probably going to want is okay, let's create our update method first so that we can go through this right here. So let's create a public void and we'll call this update. Now this is the method you're going to want to call any time that you need to update your block entity. In here, there's a few things you need to do. So first, we're going to request model data update. That just make sure our model is correctly updated. Then we want to set changed. That will make sure it's marked as dirty, and so it can be saved and load. And then we can just do if this.level is not equal to null, which should always be true, but just in case, we want to do this.level.set block updated, and we'll say world position get block state. Now I should mention, just before people go ham using this method, you need to be careful when you use it. Don't use it too often because a lot of stuff is happening here. Request model update, for example, it does quite a lot of sort of caching, and it's quite expensive. And like this, for example, it sets changed and then it updates all the neighbors and all that different stuff. And this sets the block with the specific flag, and etc, etc. You just need to make sure you don't do this any more often than you need to use it. I will show you an example of where we do need to use it, since we do need to use it. Let's go into our little inner class here, our item stack handler, and let's call inventory block entity dot this dot update. So anytime that we extract an item or insert an item from our inventory, we're going to want to update our block entity. That just makes sure everything happens correctly and everything saves. Now, additionally, we're going to need another method. So we're going to want a public void tick, and in here we can use this.timer ++, so that will just increment our timer. And then we can say if this.level is not equal to null, which as said earlier it shouldn't be, but just in case, and this.requires update. In fact, probably better if we use this.requires update first. There we go. Then we can just say update, and this.requires update is equal false. Otherwise it would be an endless loop if we didn't do that. Other than that, there are two more methods that we are actually, three more methods that we're going to want. So we're going to want a method to easily extract an item from our item stack handler. So to do this, we're going to want a public item stack extract item, and we're going to want to use the slot as the integer in here. And for this, we can just go final int count is equal get item in slot. We haven't created that yet. We can do that in a second. Get item in slot dot get count. That way we can get the current count of what is in the slot. Then we can just say this dot requires update is equal true, because it does indeed now require an update, or at least it's about to require an update. Then we can do return this dot handler dot map inventory. So we're going to map the inventory to extract an item at the slot of the count, and this is a boolean for whether this is a simulation or whether it's real. Now since we actually want to extract it, we want to just put false in here. If we are going to fake that it's been extracted, we can put true. And then we can say or else item stack dot empty. So basically if this part fails right here, we're just going to give it item stack dot empty. Let's create this get item in slot method. So public item stack get item in slot. Once again, this is going to take an int slot. Now this one is extremely simple too. We can use this.handler dot map. This is the inventory. So inventory dot get stack in slot and slot. Once again, we just want to put or else and item stack dot empty. And we need to return that, of course. Fantastic. now we're going to want the opposite of extract item, and that is obviously insert item. So public, and I guess this would be well, yeah, it needs to return an item stack just in case the whole thing doesn't manage to insert. So we might be left over with some because the slot gets full, for example. So that'll be insert item. Now this will once again need the int slot, and then it will need an item stack. So that's the stack that we want to insert. From there, we're going to want to make a copy of the stack. So let's go item stack copy is equal stack.copy. Thankfully that is already a method. Then we can go stack.shrink, and we're going to go copy.getCount. Then we're going to say this requires update, since it obviously requires an update. And then finally we can just return this.handler.map inventory.insert item at the slot, the copy false because we don't want to simulate it, or else once again item stack dot empty. Fantastic. So that should be everything, unless I'm forgetting something, of course. So now we need to come and actually create our block entity. So all you need to do is just create a normal block entity. I've already created the block, as you can see here, and I've created the block entity. I have initialized them both in block init and inside a block entity init, so as you can see there, and obviously I've created the block item as we do. Now from there, you can see I've already got some stuff in here. Since there's no point me doing this logic specifically in this video, that doesn't make any sense because this is not really related logic. But I will quickly just run through everything that's happening here. Please do note, this code is not great. I have sort of been rushing this code through, just trying to get it to work. It has caused me a lot of issues already. So I'll quickly run through. We're first specifying a limit right here. So this is just the max amount of items we want to hold in our drawer. You might not want this to be hard coded if you were to actually create a drawer, because you might want like limit upgrades and whatever. And then we just have the normal constructor, and as you can see we're passing in 1, since that is the amount of slots I want to have. Say you wanted a chest, obviously you would put 27 in here, or if you wanted a hopper you would put 5. Hoppers have 5 slots, don't they? Yeah, I think so. If you had a furnace you would put 3, etc, etc. Then I have 2 methods. No, I have 3 methods. So I have append item, as you can see here. I have prepend item and prepend stack. Now what I'm doing in here is I'm simply just appending whatever item there is. There's some honestly quite janky logic in here. I'm sure it's not great. So there's that. And then we have a load method. Now this might be a little bit confusing. So we have our original load method that we just created in here, right? So where's that? It is here. And this just deserializes the inventory. Now that's fine for most cases. However, it will not work for this case, because the thing is, Minecraft saves an item stack's count as a byte. So that obviously means the count cannot go beyond 127. Otherwise it just overflows and goes back to negative 127. So that was causing me issues, because obviously our limit here is 2 to the power of 15, which is 32,700 something, I don't remember specifically. So I had to sort of write my own load method where it would save a real count, as you can see here, And I have also done the same thing with the save method. It's basically the exact same as this method right here, this deserialize and serialize methods, except I'm adding an extra integer in here. That's basically all it is. It's nothing too complicated, but it did cause me a little bit of grief. And yeah, as I was saying, then I just have the prepend and prepend stack. In fact, I don't think these work because I think I broke them. And yeah, I'm pretty sure I broke them. If we just come into the block class, you can see that if I'm not crouching and I right click it, then I just call the append. And if I'm crouching and I right click it, then we just print how much is in there. And for the prepending, I just do that inside the attack method, and I do the same thing. But I don't think this one will work because I think I need to rewrite this logic in order for that to work. I haven't adjusted this one, so yeah. But let's give this a go. Yeah. Okay, here we are. We're back, or we are now in the game. So I placed down our block here. I haven't made a texture for it or anything. That's way too much effort. And if I shift right click it, so let's do that, we can see the current count is 0. Now if we put some leaves in, we can see it's now 64. Put some more in, 128, etc, etc. Just go all the way to 512. There we go. Now if we leave the game and come on, if we load back in, we should be able to see that it is still 512. Yep, it is still 512. And obviously, if I go into game mode survival, the theory would be that when I attack it, it's going to give me one. Probably won't. Oh, it did. I'm actually quite impressed that works, because I don't think it would work. Is that actually... Yeah, that is working. Wow. I don't suppose that works, does it? Oh, it does. Not quite, but unless I put in a really weird number. But yeah, that is it basically. Obviously, you would fix that jankiness if you were to do this for real. But yeah, that is it. So I hope you guys did enjoy this tutorial and hope you found it useful. If you did, please do be sure to let your parrot scream at that like button and subscribe. If you really enjoyed or found it useful, please share it around. And yeah, I'll see you guys in the next tutorial. Goodbye.
Now this might be look just like rubber glove on a plastic bottle, but I show you is much more, because when you give squeeze, you get middle finger that say fuck you.